In this video, I'm going to show you how to build a custom information model based OPC UA server using .NET. I'm going to begin by showing you how to create an OPC UA information model using XML, and then I'll show you how to compile the model to produce a Node.set2 file and C# code, use the model to create an OPC UA server in .NET, and then finally create an OPC UA client to consume that information. And for our OPC UA server and client applications, we're going to be using the OPC UA .NET Standard SDK provided by the OPC Foundation, which at the time of recording is available on GitHub under the general public license if you're not an OPC UA member. I'm Simon Teresa with Industry40.tv, and I regularly publish industrial Internet of Things tutorials on this channel. So if you're new here, please subscribe to make sure that you never miss any of the videos. So in the previous video, I introduced you to the OPC UA Base Information Model and companion specifications, with the Base Information Model being a group of node classes that serve as a foundation for you to describe complex systems, for example, an industrial machine. Now, how do you go about designing a custom OPC UA information model for a complex system? The process involves a few steps with the goal to produce what is called a Node.set2.xml file. The Node.set2 is a file format that is part of the OPC UA standard, and all OPC UA compliant programming language SDKs use this file to generate the code for your target OPC UA server and to populate its address space, as you will see later on in this video. There are at least 3 ways to produce the Node.set2 file. First, you could type it out using any text editor, and this obviously requires you to be well experienced in manually developing Node.set2 files. Second, you can use a graphical OPC UA model design tool such as UA Modeler from Unified Automation or UA Model Accelerator Pro from Beyond to design your model and then automatically produce the Node.set2 file along with C or C# code. These tools also allow you to import the Node.set2 file. Third, you could design the model using non-OPC UA standard XML, which allows you to intuitively design your model. The OPC Foundation fully recognizes this approach and provides tools such as the UA Model Compiler, which compiles your model design XML file into Node.set2.xml and also produces C# classes for importing into a .NET OPC UA server. The Foundation also provides XML schema definition files to help guide your custom model design process with syntax checking and autocompletion. For our demo, we're going to be using option 3. So for demonstration in this video, we're going to design a custom information model for a small batch plant. So our demo plant consists of 3 silos that hold the raw materials. Each silo has a level indicator and an analog valve for discharging material into a mixer. The mixer has a load cell for measuring the weight of product, and it also has a motor for mixing the materials together before discharging into a packaging unit. And then finally, we have a conveyor system for the finished product. Now, this here is the UML diagram showing the relationships that objects in our batch plant have with each other. And before we start implementing this in XML, we want to add callable services to our model. In other words, we want to add OPC UA server methods that can be called by a client to perform specific duties. And in our case, we're going to include start process and stop process methods to our batch plant object. So let's begin our model design. So I've got an empty model design.xml file open here on my Visual Studio Code. So first, you start with model design as the outermost element, which includes the start tag and the end tag. Now inside the model design start tag, we define the namespaces, which is basically a way to associate your model design with XML schema definition files provided by the OPC Foundation. Of note here is that we specify a namespace for our model design as OPC, so we'll need to prefix our element tags with OPC, which I'm going to do here. And then we also define the namespace for the OPC Foundation as UA. And then here we've got a default namespace. Next, I'll add the namespace's definition inside my model design. So as you can see here, we are mapping the namespace definitions to URLs used to identify these namespaces. Okay, now we can go ahead and start defining our batch plant types. Now looking at our batch plant, we can see that it is generally composed of objects such as sensors, actuators, and motors. And some of these objects are of the same type. So the first thing that we need to do is to define the generic types from which concrete implementations of our objects will be derived. So I'll go ahead and put the generic types definition here. So we begin by defining a generic sensor type. So here you see we're giving it a symbolic name, and then here we specify the base type from which our generic sensor inherits its characteristics, which is an OPC UA base object type node class. We give it a description, and then after that we specify its children. So what is our generic sensor composed of? First, it gives us an output value of type double. So we specify our first generic sensor type child as a variable with symbolic name output. And then we specify its data type as OPC UA double, its value rank as scalar, and the type definition as a UA analog type. Secondly, our generic sensor has a units property as its child. So we give it a symbolic name and specify its data type as UA string. We do the same for our generic actuator type. So our generic actuator type has as its child a variable which takes an input of type UA double, and it also gives us an output of its current position using a data type of double. And then we define our generic motor type, which also inherits from the OPC UA base object type and has a speed variable as its child. Okay, now that we've got our generic types defined, let's go ahead and define concrete types using these generic types. So I'll paste the concrete types definitions here. So the first type of sensor that we have is a level indicator. So we define a concrete type called level indicator type, which inherits from the generic sensor type that we defined earlier. And then we've got a second type of sensor in our plant, which is a load cell transmitter. So you see here that our load cell transmitter also inherits from our generic sensor type, but this time we want to extend the characteristics of the generic sensor type by specifying an excitation voltage for this type of sensor. So we put a child element, which is a variable that holds a data type of double. Next, we move on to define the concrete types from our generic actuator type. We have only one type of actuator, which is a valve. So here you can see we're inheriting from our generic actuator type. Next, we define a concrete mixer motor type and a concrete conveyor motor type, which are both derived from the generic motor type. Okay, now that we've got our concrete types, we move on to define the concrete types for each element of our batch plant and objects in which they are contained. So I'll put that definition here. So we start with silo 1 type, which contains silo 1 level indicator LI001 of type level indicator type, and silo 1 valve of type valve type, all as defined earlier. Also, we have a UA has notifier reference type for events supported by this node. Now, because we're defining the actual elements and organizing the elements into a tree structure, our silo 1 type inherits from the UA folder type. And then we also do the same for silo 2 type and silo 3 type. And then we define our mixer type object, which consists of a load cell transmitter of type load cell transmitter type, a motor of type mixer motor type, and a discharge valve of type valve type. And again, here we have a UA has notifier reference type for events supported here. And then we define our packaging unit type, which has a level indicator. And then we also define our conveyor type, which has a motor of type conveyor motor type. Okay, now that is done, we finally move on to defining our batch plant type. Okay, now here you can see that our batch plant type inherits from the OPC UA base object type, and it is composed of silo 1 of silo 1 type, silo 2 of silo 2 type, silo 3 of silo 3 type, a mixer, a packaging unit of packaging unit type, and a conveyor of conveyor type. And then we also include our start process and stop process methods. And again, our batch plant type has a UA has notifier reference types. Okay, now that we have successfully defined our batch plant type, we then move on to declare an instance of that batch plant type, and we call it batch plant number 1. So I'll put the instance declaration here. Okay, so here you can see we're declaring an instance of batch plant type, and we're calling it batch plant 1. We're giving it a browse name of batch plant number 1. And then our batch plant consists of silo 1, silo 2, silo 3, a mixer, a packaging unit, and a conveyor. And then here we link the instance to the objects folder. Okay, so I'll go ahead and save this. So we've successfully designed an information model for our batch plant. So feel free to check out the XML file, which I'll link in the description down below. Now, the next step is to compile this model design to a node-set2.xml file and also produce C# code for importing into our .NET OPC UA server. Okay, so what we want to do is to compile our model.design XML file into a node-set2.xml file and also produce C# code for importing into our .NET OPC UA server. So here I have my model.design.xml file in my C drive inside the models directory. The tool that we're going to use for compilation is the UA model compiler, which you can find on GitHub at this URL address. Now, the UA model compiler does not currently have a pre-built executable file, so the way to go about it is to clone this into your computer, build it using Visual Studio, and then get the executable file. So I'll go ahead and clone this using this command. Okay, my cloning has been successful, so I'll go ahead and open the solution. So I'll go into my C drive, and then this here is the UA model compiler that I've just cloned. So first of all, before we build this solution, make sure that here you are in release mode. Okay, and then you go to build and then build solution. Okay, so my build is successfully completed. Now let's go to the project directory. So if you go to your bin release, you'll see here there is your model compiler executable. Okay, so we'll go ahead and double click this. So here you'll see that it gives you a format for the compilation instruction. So here the first argument is the file path of your model design. The second is the file path of your CSV file, which is also produced during the compilation process. And then the last argument is the output file path. So I've already built my instruction here. So this is the file path of my model design. And this is where I want to store the model design.csv. And this is the output file path for the result of the compilation. So I'll copy this. Okay, so now I'll open up my PowerShell. Now, first of all, I need to cd to my UA model compiler executable. And paste it here, and then enter. Okay, so our model compilation has been completed successfully. Now, if you go to the models directory, so here you'll see that we've got many more files. We've got the C# classes, We've got the CSV that contains the list of our nodes. We have the node.set file, which is different from the node.set2, and we've got the node.set2.xml file. So if we open that one up, okay, so this is the node.set2.xml file, and all of the nodes in our information model are contained in this file. So if you scroll down here, you'll see that each node is assigned a node ID, and it is linked to other nodes that it is related to using the node ID. For example, the parent node ID is specified here. Also here you can see that our mixer type is an object type, and our load cell transmitter is an object since it is a concrete implementation of a type. And then you can see also that the output of the load cell transmitter is a variable. Again, feel free to go through this file to understand the contents of it much better. Now, another file of interest here is the predefined UA nodes. Okay, so we've successfully compiled our OPC UA information model. The next step is to create an OPC UA server in .NET based on this information model. Okay, so I'm going to show you how to create a .NET OPC UA server using the information model files produced by the UA model compiler. Okay, so I'm on Visual Studio, so I'll go ahead and create a new project. Okay, and then I'll create a Windows Forms project. Okay, and then we'll call it batch plant. Okay, and then I'll go ahead and create. Okay, so my project has been successfully created. Now the first thing that we need to do is to install the OPC UA SDK using a NuGet package. So I'll right click on my project, go to manage NuGet packages, and then here I'll search for the OPC Foundation.NET Standard OPC UA, and then I'll go ahead and install this. Okay, my OPC UA package has been successfully installed. So now before we proceed, we need to copy our information model design files into our project. So I'll go to the directory, and then I'll copy everything. And then paste it into our project. Okay, now I'll go to my program C# file. Okay, so first of all, we're going to comment this statement out because we don't want it to start running that form. And then we include the assembly reference for our OPC UA package. Okay, so now whether you are creating an OPC UA server or client, they are both referred to as OPC UA applications. So the first step is to create an application instance. So I'll put the code here. So here basically we're creating an application instance, and then we specify that this is a server application type, and then we give it a name. Okay, and then when that is done, our next step is to configure our OPC UA server. And there are two ways to do that. It's either you do it in code, or you put your configuration details in a .config.xml file and load it at startup. So I've got my configuration settings on this XML file here called batchplantserver.config.xml. So I'll go ahead and open it up. So basically with this configuration file here, you can configure things like your application name, security configurations, your transport configurations, and this is also where you specify your base address, which includes the port number. So I'll go ahead and copy this config file into my project as well. And then after that, I'll put the code for loading our application configurations here. And then I'll highlight my config file here so that I can copy its file path. And then I'll put it as an argument for my load configuration method. And then after that, we put our statement for checking the application certificate. Okay, and then when that is done, we're ready to instantiate our OPC UA server object and start running it. But first of all, we need to create the server object. So I'm going to go ahead and create a class here. And then I'll call it batch plant server. Okay, now for this class to be an OPC UA object, it must extend the standard server class in our OPC UA SDK. So I'm going to do that here. Okay, now our OPC UA SDK uses the concept of a node manager to import and manage your OPC UA server nodes. So we need to override a method in our standard server object that allows us to create a node manager. So I'll put the code that does that here. So as you can see here, we're creating a custom node manager called batch plant node manager. So we'll need to create a class in our project, which we're going to do shortly. For now, let's override another method that allows us to specify the server properties. Okay, so this here is your product information. Okay, so let's go back to our main method in the program C# file. So here we start our server. So we'll also pass that application instance to our form. And then from there, we go to our form 1 and make sure that we've got a constructor that accepts our application instance as an argument. So I'll put the code here. And then here we make sure that we declare our instances. Okay, so when our application instance is passed to form 1, we then want to display the endpoint URLs in a combo box. So we're going to go ahead and create a combo box. Okay, and then I'm gonna go into the code, and then I'm gonna add the code that populates our combo box with our OPC UA server endpoint URLs. Okay, and then we go back to our program C# file. Now here we make sure that we put this in a try block. And then here at the top, we put the code that checks to see if our application is running as a service. Okay, let's go ahead and create our node manager class, which is responsible for importing our information model into this OPC UA server. So to do that, I'll go to my project and add a new class. Which is our batch plant node manager. Now, first of all, for this class to be an OPC UA node manager, it needs to extend a class called custom node manager 2 in our OPC UA SDK. So I'll do that here. Okay, and then from there, we use this constructor to set our namespaces. Now, if you go back to our model design here, you'll remember that we set our namespace's name to batch plant. So we're getting that namespace from our model and using it to set the namespace in our server. And then here we get the configuration information of our node manager. So we need to have a batch plant server configuration class. So let's create that before we proceed with our node manager. So here we create a data contract for our class for serialization. And then we add a constructor for our class. And then we add our initialization methods. Okay, now back to our node manager. We go on to override a method that allows us to load predefined nodes. So as you can see here, we're specifying that we're loading our predefined nodes from a binary resource. And if you check here, you'll see that it also allows us to load from XML. So I'll leave it as binary and then copy the file path of our binary node set file and place it here. And then next, we override the method for creating the address space. So this is where we call our load predefined nodes method. And then from the loaded nodes, we look for our batch plant 1, which was instantiated during our module design. And then we make sure that it is strongly typed within our server for easy manipulation. Now, this is also where we set the event handlers whenever our OPC UA server methods are called. So we can go ahead and put our event handler methods. So this is where you put the logic within your server that needs to take place whenever the onStart process method or the onStop process method is called. And then if you need to simulate the values of your nodes, you can start your timer here. Okay, before I show you a simulation example, let's make sure that all our variables are declared. Okay, now that we've declared our types, we can go ahead and put an example of a simulation. So we could say batch plant 1 dot mixer dot load cell transmitter dot output dot value is equals to, say, 85. So each time our timer ticks, the load cell transmitter value gets assigned a value of 85. And then our simulation method obviously needs to receive an object. Okay, so we've successfully built our OPC UA server based on our information model. Now if I go ahead and run that, okay, so our server is successfully running. So you can see here we've got our combo box that contains our endpoint URL. Okay, so I'm going to copy this endpoint URL and then connect to this server using an OPC UA client. So I'm going to use UA expect for that. Okay, we'll create a new connection. And then I'll place my endpoint URL here. And then click OK. Then I'll right click and connect. Okay, and then I'll choose to trust this server certificate. And then continue. Okay, so as you can see here, there is our batch plant number 1. And then we've got our conveyor, which has got a motor with speed. And we've also got our mixer with the discharge valve. We've got our load cell transmitter. We've got an output value. We're going to drag it there, and then you see we've got our value of 85, which we've simulated on our server. And then you can see we've got the rest of our objects here, including our start process and stop process methods. Okay, so we've successfully created our information model based OPC UA server using .NET. Next, I'm going to show you how to create an OPC UA client using .NET. Okay, so I'm going to show you how to create an OPC UA client using .NET and the .NET Standard SDK. So I'm on my Visual Studio here. So I'll go ahead and create a new project. Okay, so I'll create a .NET Core console app. Okay, I'll call this batch plant client. Okay, so my project has been successfully created. Now the next thing that I need to do is to install the OPC UA .NET Standard SDK. So I'm going to right click on my project and select Manage NuGet Packages. Then I'm going to go to Browse and then search for the OPC Foundation .NET Standard OPC UA. So I'm going to go ahead and install that package. Okay, so my package has been successfully installed. Now I'm going to go back to my program C# file. Okay, so the first thing that I'm going to do is to put the code that creates an application instance and its configuration parameters. Okay, so first of all, we set our configuration parameters, which includes our application name, application URI, our application type, and we're also setting our security configuration and transport configurations, among other configurations. Okay, and then from there, we create an instance of our application. And then we set our check application instance certificate to false. And then from there, we specify an endpoint to connect to. So I'm going to go ahead and start our batch plant OPC UA server so that we can connect to it. So I'll go to my batch plant server project directory, going to the bin debug, and then I'll start my batch plant server application here. Okay, my batch plant server is running, so I'll copy this endpoint and then put it here on my client. And then next, we put the code for browsing through our OPC UA server address space. So here we're creating a session, and then we're using session.browse to browse through the objects, starting from the root folder. And then for each node, we show the display name, browse name, node class, and the node ID. Okay, so I'm going to go ahead and run our OPC UA client. Okay, so as you can see, there is our instance of a batch plant type called batch plant number 1, which consists of silo 1, silo 2, silo 3, our mixer, the packaging unit, the conveyor, and we have also got our start process and stop process methods. Okay, so that brings us to the end of this video. So if you found this video useful, don't forget to give it a thumbs up and share it with your connections.